Welcome to The Explainer. Today, we're diving into a concept that secretly messes with almost every headline you read and every study you see. Sampling error. You ever feel like you're getting whiplash from the news? One day coffee is a superfood that's going to save your life, and the next day, it's basically poison. How can both of those things possibly be right?
Well, a lot of the time, the answer lies with this one sneaky but critical idea called sampling error. And it's so important because when it goes wrong, it can completely kill otherwise perfectly good research.
So what is it, exactly? It's actually pretty simple. It's just the natural difference between what a researcher finds in a small group, that's the sample, and what's actually true for the entire group they want to know about, that's the population.
Let's make this super simple. Imagine the entire population is a giant pot of soup. I mean, a massive pot. And the sample the researchers are working with, that's just one single spoonful they take out to get a taste.
And here's the thing you just can't get around. No matter how well you stir that soup, that one little spoonful is never ever going to be a perfect, exact copy of the whole pot, right? That tiny little difference, that's the sampling error. All right, but what happens when that spoonful is just way off? Like, what if you only get carrots and miss the chicken entirely? That's when sampling error gets really high, and it kicks off this awful domino effect that can just destroy the quality of the research.
So, a high error basically poisons the study in three big ways. First off, your results are just plain wrong. And because they're wrong, you can't really apply those findings to anyone in the real world. And finally, it messes up the statistical tests themselves, making the whole conclusion totally unreliable.
This hits right at the heart of something researchers call external validity. I know, it's a fancy term, but all it really means is, do the results from this little experiment actually matter out there in the real world? When sampling error is high, the answer is a big, resounding no. And check this out. This visual just nails the problem. The bullseye, that's the truth, right? A good study hits it or gets really close. But with high sampling error, you're not just off, you're all over the place, completely missing the real target. Now, this isn't just about getting a fuzzy or slightly off result. This kind of flawed sampling can lead researchers into making two very specific and, frankly, very dangerous types of mistakes. You see, in any study, a researcher is basically making a bet on their hypothesis. Based on the data from their sample, they can either make the right call or they can fall into one of two major traps. We call them type 1 and type 2 errors. So a type 1 error is a false positive. Think of it like a fire alarm going off when there's no fire. The research screams, "We found something important," when in reality, there's nothing there at all. This can lead to useless new policies or treatments based on a complete illusion. A type 2 error is the opposite, and it might be even scarier. It's a false negative. This is the fire alarm staying silent while the house is actually burning down. The research says, nope, nothing to see here, and completely misses a real problem. Or maybe even a real cure. So is all hope lost? Is all research just a shot in the dark? No, not at all. The good news is researchers have a whole toolkit for fighting back against this stuff. And you know what? Their two biggest weapons are surprisingly simple. First, increase the sample size. Basically, use a bigger spoonful. And second, use what's called probability sampling. All that means is making sure your sample is chosen randomly, so every ingredient in that soup has an equal shot of being tasted. And you can literally see the difference right here. On the left, with a small sample, the results are all over the place. They're really spread out. But look at the right. When you increase the sample size, see how the results get so much tighter, so much closer to that bullseye? It makes a huge difference. So how do they actually get that randomness? Well, they have a whole playbook of techniques, like the ones you see here. They're all designed with one goal in mind, to take human bias out of the equation and make sure that sample is a true, tiny reflection of the bigger population. Okay, let's bring this all home. Why should you, someone who isn't a statistician, actually care about any of this? Why does this matter in your life? Because honestly, understanding this one concept is like getting a superpower. It makes you a smarter, more critical consumer of information. It gives you the tool to look past the flashy headlines and really question the data that is thrown at you all day, every day. It gives you the power to ask the one critical question that can change everything. So the next time you see some big, shocking statistic, you'll know to ask yourself, okay, but how big and how random was the spoonful?